Wednesday, May 3rd, continue with the 9.3 notes. So there's 3 categories of card that we're talking about. So we have 3 circles in our Venn diagram. It's a triple Venn diagram, okay? That's the first thing we want to note. So we draw a triple Venn diagram, okay? And then at this point, the next thing you want to do is you want to try to fill out as many of the bubbles as you can based on the information they gave you, okay? So they tell us explicitly 6 like only Fords. So in the only Fords category, we can put a 6. We following, okay? 3 like only Buicks, 2 like only Chevys, okay? And they tell us that what? 5 like all 3, right? 5. So we can fill out those 4 right off the bat. Any questions about why we can do that? Okay. We don't know the other 3 categories, do we? So I just labeled them X, Y, and Z. We don't know. Boo-hoo, okay? All right. All right. We do know what? We know that 19 students total like Buicks, okay? So the 3 who like only Buicks, plus the 5 that like all 3 cars, plus the X plus your Y, all 4 numbers in this Buick circle, they have to add up to 19. So I wrote down here, 3 plus 5 plus X plus Y equals 19. Questions on that? I did the same thing for the other 2, okay? So let's combine these and simplify. We get X plus Z equals 8 for that one, okay? This equals 11. 19 minus 11 is 8. This gives you X plus Y equals 11. This gives you Y plus Z equals 5, okay? So we have 1x plus 0y plus 1z equals 8. 1x plus 1y plus 0z equals 11. 0x plus 1y plus 1z equals 5. Okay, so put that in your calculator then, using your matrices and stuff. I like to use Gauss-Jordan. I think it might be pronounced Gauss-Jordan. Sorry. I'll start pronouncing Ava's last name Jordan. Ava Jordan. Maggie Gauss and Ava Jordan. Was that? Jordan? I don't know. It's a good question. I have no idea. Can you go fill it? Can he go fill it up? No? Okay, no. Okay, yeah. With water. So 1 at 1. So I'm doing this with matrices. Okay, so I put in my calculator a little review of last chapter, since we probably all forgot it. Right, I put in all the coefficient matrix. You guys remember that? Okay, I'm going to do second matrix. I want, what function do I do? Ref, yeah, R, E, F. I want lots of R's. Oh, wait, let me go back to the home screen. I do R, E, F. Of, what do I want? Okay. Boom. X equals 7, Y equals 4, Z equals 1.
How did you get that? How did you get that? I'm just missing something.
The matrix I put in my calculator, it's this system. Are you asking where I got this system? Do you see where I got this from?
No.
Okay, do you see where I got this from? Partially. So the first line, right? How many total students like Fords? What does it say? 6. Okay. Wait. How many total like Fords? 19. How many total like Fords? So what's going on here is the 6 students who only like Fords, plus the 5 students who like all 3 of the cars, plus the X students who like Fords and Buicks, and the Z students who like, Chevys and Fords. The 4 numbers in the Ford circle, 6, X, 5, and Z, those have to add up to 19. So that's where I got that first equation from. okay? Then I repeated that for the other two categories of car, okay? So then this system, I did that kind of fast. This adds up to 11, right? Subtract the 11 over, you get 8. So that's where these three came from, okay? And then it's easier for me to put it in my calculator as a matrix if I write out my missing variables. So I put a 0y here, I put a 0z here, 0x here, okay? All right? Any questions? Okay. Miss, you already have it, Lanyard. I walk past the Costco box every time you go to Costco, and I want to buy it so badly, but it's not in the budget, so. What? Really? You like Tori Go-Go's? That's awesome. I love Go-Go Squeeze. Anyway, yeah, so then we can fill in the rest of this Venn diagram. So x is 7, so we can replace that x right there with a 7. Okay, was y 4? Y is 4, and z is 1. There you go. At this point, it's really easy to answer all the problems. So, how many like both Chevys and Buicks? Would it be 4 or 9? Technically 9. Depends like what you mean. Like only both Chevys and Buicks, or like both Chevys, at least both Chevys and Buicks?
I think they're asking for the probability.
Oh, okay, thank you. What is the probability that if a student is chosen at random, he'll misogynistic. Could be a girl. Gosh. Only guys can be into cars, guys. I apologize. I'm kidding. Come on. This is terrible. Anyway, yeah. So how many students like both Chevys and Buicks? It's the total that like both. So 5 students like all 3 of them. 4 students like just Buicks and Chevys. That's okay. So there's 9, and then for probability, what do I need to divide by? The what? 32, the total students. Okay. None of the cars. What's the probability that someone likes none of them? Isn't that 0? None of the cars. Oh, not everyone voted. Yeah. So here's how you do this. There's 32 students total. Okay. So what do all the numbers inside my Venn diagram add up to? 3 plus 7 is 10, plus 6 is 16, plus 5 is 21, and then plus 1 is 22, 24, 28. So those 4 leftover students, I need to write that 4 out here in the box. Okay. So 4 students just don't like any of the cars, okay? That's like someone like Mrs. Mills, who rejected me from the classic car competition for show. What? She rejected me. She left me out. Inclusiveness and diversity, right? Nope. Not if you drive a 2014 Honda CR-V, apparently. I think that's a classic car. Right, so 4 out of 32, right? There are 4 of those students I can choose out of 32. What's that?
Nothing, we were looking at the CRV, pretty artsy.
Pretty nice.
I feel.
It'd be just so funny just like to see like a modern
Yeah.
car, like amongst all like the classic cars. Like 2016 Subaru Forester. Like a minivan or something. My 08 Grand Caravan.
Don't you?
Oh, wait, hold on.
I drove an 08 Grand Caravan this school senior year. It was so nice. Such an upgrade for my Spectra. What's that?
Mine's a 06.
06 Grand Caravan? Is it like the square shape? Like it looks like a rectangular prism almost? Yeah. They're really nice. They drive pretty smooth. You can fit a lot of...
Not mine.
Oh, okay. All right. Let's move on. 68 seniors got asked if they like green. 23 said they like purple. 32 said they liked yellow. 6 liked all 3. Okay, this is like a pretty much identical problem, okay? So how many categories are there? 3. 3 categories. So I'm going to make a triple Venn diagram. Triple Venn diagram. I got to make this perfect. That's pretty good. That's almost perfect. And make it a little bigger. Okay. Right. Let's make this green, yellow, purple, purple. Okay. What can we fill out here? What can we start filling out?
23 like purple.
23. We can't. No. So that's like that means 23 liked purple means the sum of these four numbers is 23. So we can't fill that out yet. That make sense?
11 like only yellow.
So 11 liked only yellow. Okay, good. Was someone else over here? I heard another voice.
6 like
6 liked only green.
no, all 3.
Oh, all three. Thank you.
6 like purple, 4 like only
Only purple. Okay. And 15 liked only green. Okay. Exact same thing going on here, right? Let's call this X. Let's call this Y. Let's call this Z. Okay. So 15 plus 6 plus X plus Y has to add up to what? How many like green total?
43.
43. Okay, right? 11 plus 6 plus X plus Z equals, how many liked yellow? 32 said they liked yellow. And we should like recreate this. 6 plus 4 plus Y plus Z has to add, how many liked purple? Purple. How many total liked purple? 23. Yeah, nobody likes purple. Just kidding, I love purple. It's like my favorite color now. Yeah, what? 6 plus 4 plus 1. Okay, so let's write this so we can get it in our calculator. Okay, so this is, what's 43 minus 21? It's 22. So it's X plus Y equals 22. I'm just simplifying some of the numbers. Are you okay with this? X plus Z equals 15. This is what? Y plus Z equals 13. Okay. So writing this out in a form that's easier to put in my calculator, X plus 1X plus 1Y plus 0Z equals 22. 1X plus 0Y plus 1Z equals 15. 0X plus 1Y plus 1Z equals 13. Okay, so that's the matrix I'm going to put in my calculator. My calculator. Can I plug and chug? What would I plug in for X, Y, and Z? Like substitute and stuff? Yeah, you could. It'd just be a lot more work. If that's your thing, though, you can do it. 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 22, 15, 13. Quick little review here, right? So I got my chart here, or my matrix, okay? You guys see why I put the numbers where I did? Okay, cool. Second quit, I want second matrix math, I want REF. Second matrix A. Boom. X is 12, Y is 10, Z is 3. So 12, 10, 3. So replace these 12, 10, and 3. There we go. Okay. What are they asking me? What's the question? What's the punchline here? That he or she will like at least one color, okay? How many students like none of the colors? So we have 68 total, right? 68 seniors. How many like none of the colors? What do all these numbers add up to? What? 58, 15 plus 12 plus 11 plus 10 plus 6 plus 3 plus 4. I got 61. So there's 60, these all add up to 61. So how many students like nothing? Just like hate colors? 68 minus 61, which is 7. Okay. So what's the probability that a student I pick will like at least one color? 61 of the kids like at least one of them. 61 out of 68. Okay, so the number who like at least one color divided by the total number, right? 7 students, they hate colors. Okay. They also, their favorite food is tofu. They're just plain tofu. Favorite drink is water.
Plain tofu is gross.
Their favorite drink is well water.
That's well water.
It depends where you are. I've had good well water.
I'm not.
Right, their favorite day of the week is Monday. Favorite weather is 40 and rainy. They're gonna get a pet like ant when they grow up or something.
They sleep with socks on.
They sleep with socks. Hey, I sleep with socks on.
No, you don't.
Yeah, it started during COVID. It started during COVID. So what happened was like, I kept like it was weird. Like I would walk around my house barefoot at home, and I think like so in college you never like walk. I never walked on my dorm barefoot. I always wore Birks, so I think my feet just got used to that. Then when I got home for COVID, I like walked around barefoot, and like my toes would like chafe on the carpet, and it hurt. So I had to start wearing socks, and then I had to start. But I started wearing socks like literally like all the time, except when I showered. And so then like so I just started sleeping in socks. No, I do not sleep in jeans. That's horrible. Yeah, these people sleep. They sleep with shoes on and jeans. They sleep in jeans. Guys, stop getting me off topic. Okay. Here we
I was
go.
watching a video from class yesterday, and there's like a 6-minute period where I just hear you in the back here like talking about like gambling or something. I was like, okay.
I know. I gotta be careful. I know you like watch all my videos.
Yeah, you do.
Which I really appreciate.
Otherwise, I will have no idea.
I just gotta be careful to. I can't just like say whatever I want.
Well, you can't, 'cause I wouldn't say.
I wouldn't say anything. Ava Jordan stinks. Hey,
Kate's gonna hear it now.
what's that?
It's gonna be about Kate, so she's gonna hear it.
All right, Miss White skipped the rest of these notes. Let me look at the quiz and see if you need them. Let me look at the quiz. Yeah, we need this. Okay. What's that? Grab some Durman. Grab some H-dub. H2. Some H-double-O. Okay. All right. So we're gonna draw a Venn diagram. The probability. Here's how you do this. I'm just gonna tell it to you step by step. Okay. That like upside down U right there, that's called intersection. It's called an intersection symbol. What it means is and, or like both. Okay? So where do you think I put point 2? Someone say in the middle? Yep. In the middle. That's a song by Jimmy Eat World, right? It is. Wait, no, it's what was that? Why don't you just meet me in the middle? All right, so you put that in the middle. That make sense? Okay. All right. Now the probability of A is 0.6. So what's going on is the number inside this box plus the number inside this need to add up to 0.6. So what number's here? 0.4. 0.4. What number's here? 0.3. Okay. now every number on the screen here needs to add up to 1. What do they add up to right now? They add up to 0.9. So what do I put in the corner? 0.1. There you go. So I filled out the Venn diagram. Another little trick I got to give you here. Okay, another thing I need to explain. A prime means not in A. B prime, that's a little apostrophe, means not in B. I told, so there's this concept in calculus called double prime. I told Danny O'Neill, I told him to just call me Coach Double Prime because Deion Sanders is Coach Prime, and I said, you guys need to call me Coach Double Prime because I'm the calculus teacher, one of the calculus teachers, and it's like cool to be double prime, kind of. So I'm Coach Double Prime. I teach people how to do second derivatives. Right? So probability of A and not B. So what's the number that's in the part of the Venn diagram that's in A but not in B? It's in A but not in B. So let's look at the B circle. I got a 0.3, I got a 0.2 here, right? So 0.2 is not in the running. Which number is in A but not in B? 0.4. Remember, the upside down U means and or both. Okay. Which number is not in A but it's in B? 0.3, right? That 0.2 is in A, right? It's in the A circle. So 0.3. Okay. Which number is not in either of the A or B circles? That's not A and not B. 0.1. Okay. This is probability of A given B. There's nothing in the notes key. I remember this. There's a formula for it that's really easy. I just don't remember what it was. Conditional probability formula. Here we go. Got it. Okay. Okay, the formula for this one is, I do, bless you, probability of A and B divided by probability of just the second one. So whatever the second one is. Copy down. I remember doing this in college. I remember studying in college and being like, the bottom one is whatever the second. Yeah. I remember doing this in college. The bottom probability. Gosh dang it. It's whatever the second letter is here. So then, this line. Sorry, the line means given. Given. So this is probability of A given B. That's how that's pronounced. Okay, that's what the line means given, okay? So what this means is, I say Elise, I threw a dart at this Venn diagram from the back of the room, all right? It landed in B, it landed somewhere in this circle.
Yeah.
Given that it landed somewhere in this circle, what's the probability that it also landed in A? So it'd be 0.2 divided by the whole thing, right? It's probability of A and B. What's the probability of A and B here? 0.2, right?
Oh, yeah.
What number's in both A and B? It's 0.2. What's the probability of just B, being in B? Any part of B. Any part of B would be 0.5. Yeah. So another way to think of this, probability of A given B, it's the part that's in A and B divided by the total that's in B. Does that make sense? No, it doesn't make sense? All right, we're just chilling, I guess. It's fine. Just don't come crying to me on test day. Okay. Unless you're trying. If you're working hard, then please do come crying to me. I'd actually really appreciate it. I don't want you to cry, Like I don't want, but if like you are stressed, like please come to me. I'll help you out. I've not made anyone cry.
To your knowledge.
Like me, I don't think me as a person. I hope I have. If I have, I'm sorry, but I think my class has. My class has.
They just found it back.
So it'd be 0.4, right? 0.2 divided by 0.5. All right. Yeah. You guys want help anytime? If I'm at home, I can hop on Zoom. If I'm sleeping, I can just hook up my phone to my email. If I get like an email, it'll like wake me up. I'll hop on. No, I'm kidding.
I need help.
3 a.m. All right. Cool. Let's skip this next one because these are going to be on. This is something like this is going to be on your quiz. Okay. So these, you can do it with this conditional probability formula. You probably don't like that though. So let me think of a good way to explain this. If it rains, probability Joe does his homework 40%. Doesn't rain, probability he does is 10%. Okay, if it's nice outside, he's going to go play. Okay. Given probability rain is 30%, find Joe's probability to homework. Okay, so what you do is we're going to make a little chart here. Okay, we're going to make a little chart. Start with the event that's after the given. Start with the event that's after the given. Okay? What word comes after given? Are we talking about homework or the rain? Start with the given. Okay? So we're talking about the rain, right? So it either rains, so rain, no rain. What's the probability of rain? What's the probability of rain? It says right there. Yeah, 0.3. What's the probability of no rain? Okay, you start with that, okay? Now if it rains, let's go here on the rain side of things, okay? I'm going to start color coding this. On the green side, on the rain side, right? If it rains, the grass will be green, okay? Okay, if it rains, what's the probability? So Joe either yes homework, he does his homework, no homework. Okay? If it rains, what's the probability that he does his homework? 0.4. Okay. And then if he does no, what's the probability that he doesn't do his homework? Be what? No. 0.6. Any two like prongs here have to add up to 1. If that makes any sense. Okay. All right. If it doesn't rain, what's his probability that he does his homework? Yeah, 10%. Boo. Come on, Joe. What's the probability that he doesn't do his homework if it doesn't rain? 0.9, right? Those two numbers have to add up to 1. Okay. All right, and then you multiply across. I'm going to explain this. You multiply across for answer. Okay. This is probability of doing homework. Okay. So we have two scenarios here. It either rains and he does his homework, or it doesn't rain and he does his homework, right? What's the probability of just it rains and he does his homework? What word did I just use in that sentence? Okay, which conjunction did I use? And, right? The probability that it rains and he does his homework is what? 0.3 times 0.4, okay? So 0.3 times 0.4. Okay, or the other scenario, or I just said or. What symbol am I going to put down? Plus. Okay. The other scenario in which he does his homework, it doesn't rain and he does do his homework. So 0.7 times 0.1. So 0.19. guys feeling okay about this? We need to see a couple more examples. You're going to see like something like this on the quiz tomorrow. It's Thursday. We don't have class Friday. I would have made it Friday. It's like a small quiz. So just blow it off. No, don't blow it off. Please don't blow it off. Very bad idea. Okay. Good. Let's go to this next one, okay? Cafeteria serves noodles and salad, okay? So what do I start with? Do I start with the probability of noodles or the probability of salad? You start with the given, right? You start with the noodles, okay? So probability of noodles. Probability of noodles. Probability of no noodles. Man, this makes me hungry. Probability of noodles, probability of no noodles, okay? Given that they just serve noodles once each school week. So on a given day, what's the probability that they're going to serve noodles? 1 in 5, 20%, right? 0.2. What's the probability that they don't serve noodles? 0.8. Right? For any like two pairs, like I don't know what to call this. Any like two pairs here need to add it to 1. That makes sense. Okay. Man, my throat's really sore. I think I'm dehydrated. All right. And then let's say they serve noodles. If they do serve noodles, what's the probability of salad? What's the probability of no salad? No salad. Probability of salad given that they serve noodles. What do they say? 80%. 0.8. And that salad and no salad here have to add up to what? To add up to 1, right? So what's the probability of no salad here? Yeah. And then go to the no noodles. If they don't serve noodles, there's a 50% chance they'll serve salad. So then there's a 50% chance there's no salad. Not a big salad guy, to be honest. All right. I pay for food that has, right, salad just doesn't taste like anything, has no flavor. Unless you put dressing on it, but that's cheating. I'm kidding. All right. What are they asking me? What do they want? What do we want to find?
Probability will serve
Salad, right? So what am I going to do? (0.2 times 0.8 plus 0.8 times 0.5. Okay, does that make sense? Feeling good? Feeling all right? Feeling good, Ryan? Okay, right? They serve noodles and they serve salad, right? So there's a times, or they don't serve noodles and they serve salad. What's that? 0.2 times 0.8. 0.56. Good stuff. Good stuff. All right. And there's another one. Another one. Okay. C. We're going to see one like this on your quiz tomorrow. You can try this on your own real quick. Try it on your own. I'll give you 5 minutes. I'll come around and help you. Little hint here, they don't say given in the last sentence, they say if instead of given. you guys are doing that. So ask me if you need help. Otherwise, I'm going to look at the 9.4. Ooh, sequences. I'm going to write down some formulas real quick. Okay? "37 seconds.
No, I'm not actually.
Start with soccer, good. 0.7. 0.7, what would the other number be? 0.3. And you should be doing crossing. All right. So what was the category that came after if? We're talking about soccer or lacrosse after the if statement. Soccer. Okay. So we're going to do soccer. Anyone here play soccer? Play soccer? Nice. No soccer. Okay. Probability of soccer is what? 0.7. So then what's the probability of no soccer? I love it. Music to my ears, okay? All right. If we're playing soccer, then what's the next category? Lacrosse. Lax. No lax. Okay. What do they say if you play soccer? If you play soccer, 0.62, right? Probably would be lax for us. If you play soccer, it's 0.62. There's just a little overlap. Then what do these two need to add up to? 1. So what's the other one? Good. Probability of lax. No lax for if he doesn't play soccer. No soccer in lacrosse was what? 0.48. And then the other one, these have to add up to 1. This is 0.52, right? Okay. And what are they asking? Find the probability of a student playing lacrosse. Are you guys good at this point? So the two like yes lacrosse trails here. All right. Okay, so we do 0.7 times 0.62 plus 0.3 times 0.48. All right, questions, comments, concerns? Feeling okay? So I got 0.578. Is that what you guys got? Okay, feeling okay? Okay. So I think we're at least on the brink there. All right, good stuff. All right, we got 7 minutes left. We got to start 9-4. Okay. Good stuff. All right. Arithmetic sequences, examples. I guess I'm supposed to write down the example. All right, an example of we're going to talk about sequences. Okay. All right, so I'm going to take, someone give me a number. 5. Cool. That'll be the first number in my sequence. Let me write this a little thicker. Someone else give me a number.
18.
Okay, something smaller.
12.
Smaller. 2, okay? So to get the next term in my sequence, to get the next number in my arithmetic sequence, I'm going to add 2 to 5. So what's that? And then what's the next number? 9. What's the next number? What's the next number? What's the next number? 15, yeah. So what I'm doing is I'm just adding the same number every time. That's what an arithmetic sequence is. You're adding the same number every time. Okay? The number you add every time, is called D. It's called D. It's called the common difference. Sorry, my handwriting's bad. So what's my D here? What's the D equal to here? 2. Okay. The formula for the nth term, we call that a sub n. Formula for the nth term is a sub n equals a sub n minus 1, so the previous term plus d. Okay? So here, to get the second term, to find what the second term is, I go to the first term and I add 2. Does that make sense? So the subscripts are just fancy. They just look fancy. They're not fancy, though. Right? So the first term is like first term. We call that a sub 1, second term, a sub 2, and so on. So on and so forth. Okay, don't be scared. Don't be scared. It's just fancy. It's all bark, no bite. Okay? It's like the word like illustrious. Right? It just means like beautiful, awe-inspiring. Yeah, that sort of thing. Okay? All right, give me a number. Miss Ewer. Give me a number. 6. All right. Miss Zhao. 9. So I'm going to do 6 times 9. What's that? 54. Okay. I'm going to do 54 times 9. That's 486. What's 486 times 9? 4,374, right? Okay. So a geometric sequence is when you multiply by the same number every time. It's when you multiply by the same number every time. Okay? The formula for the nth term, I wrote it on the board. So to get a term in my sequence, I go to to get one of the terms in my sequence, any of them, I go to the previous term and I multiply by that number called r. The same number, that same number here, it's called r. It's called the common ratio. That same number you multiply by, that here it was 9. Okay. All right. That make sense? Yeah. One thing I do want to say, sequences, it's just a list of numbers. Sequence is a list of numbers. List of numbers separated by commas. Okay, I'm going to say that it'll make more sense when we talk about series, because I think it's easy to get the two confused. I often get the two confused myself. Okay. All right, that's a good stopping point. Let's do the 9.3 homework for tomorrow, and we'll also have a quiz. So, yeah, we'll also have a quiz.